recording is started. Let me just share my screen. Right, so good morning again, everyone. And so I just wanted to talk about, first of all, in Canvas, I made a new module, right, called the first steps with today's date. This is where you'll find the recording of the demonstration and lecture today once class is ended and I get it uploaded. As well, there'll be a link to the assignment over the weekend. And then there's also a context model. So I'm giving you a Rhino model to use, which you can find here and download. It's 2 megabytes, shouldn't be too big of a deal. We'll talk about that in a minute because that's what I'll be using for the demonstration here. But before we get into our demonstration, into those details, let's talk more broadly about another example from architecture and engineering that use parametric design in order to do something similar to what we're about to undertake, right? So I revert to Waterloo Station, a project for a train station in London that was designed by Nicholas Grimshaw Partners. So that's an international office, their main office based out of London. As you can imagine, a train terminal, first of all, if you think about train terminals, they're usually large spaces. And they're usually considered these sort of gateway spaces where you get out of a train and then it's your first impression of a municipality, of a city, of a place, right? And so you think about some of these sort of pieces of architecture that also serve as sort of transportation infrastructure, but also as these sort of gateways to a city. They're usually these grand airy spaces. They're usually made to sort of fill you with awe and wonder. And no surprise, a lot of them do use these sort of large spans, and trusses are a great way to sort of span or make or to negotiate a sort of long span. This is no exception. As you can see here, again, a grand space, right? With all of these sort of trusses. What's interesting is that due to the site constraints, right, the shape of the station and the shape of the tracks that it's spanning are curvy. And they actually taper. So so if you, I guess one way of looking at it is if you go from, let's say, the top right to the bottom left of the picture, it sort of tapers, or you could say that it sort of swells or expands the sort of footprint as I move from bottom left to top right. So you can see that they worked out with the structural engineers, this sort of double truss pin system, right? A truss going up this way, a truss going up on the other side, and then a pin connection. And then that pin connection is sort of a spline or a spine that sort of runs through along the railway tracks. And so again, they were sort of negotiating this, but again, it's a series of trusses. All of them are sort of from the same family. They're all very similar. They're sort of from the same genes or genotype, even as each one is slightly different based off of the site constraints, right? So as you move across the site, each one changes both in terms of its span and therefore each of the components that comprise each truss. Right? Again, I think when you look at the sort of this physical model, right, you can start to see those site constraints, right, as it moves across this rail yard, and then how again the sort of both the footprint changes as it as a sort of serpentine along the tracks. But then also how the footprint expands as it moves along and incorporates more of the tracks, and as tracks bifurcate. All right, and again, so hopefully you can see this. I was just doing a quick Google search. I didn't have time to give you a proper PowerPoint here. But as you can see, each of these trusses differ, right? They sort of get shorter and they get longer and then they shorten up again, right? At the same time, they also get taller as they sort of form a larger arch over the tracks, and then smaller arches. Okay. So this does have real world implications, right? Here's a cross section or a building section through that canopy, right? Where you can see the idea here along the longer sort of truss was to sort of have the webbing along the inside, and then to have it inflect and have the webbing on the outside. It's a pretty interesting system. All right, there's a typical plan of a typical bay, right? Where you can also see that these trusses are three-dimensional, just like we're dealing with, right? So they begin to expand outwards. There's three sort of chords rather than just a top and a bottom chord. quite an interesting early example of parametric design. All right, and so what I'm going to do is go over the first part of what I want you to do over the weekend here, which will be the sort of final model that you're developing for project one, right? So for project one, for the remainder of this month, you'll be first generating a sort of truss system, a lattice system, the generative lattice. And then we'll be developing some visualizations of it, both in drawing form, so some quick diagrams, as well as orthographic drawings, as well as some experiential perspectives. All right, and so what I'm going to do is I'm going to give you the context model, right? So that you have basically the two sort of facades of a building, or you could say two building facades that you're going to span over the top of in order to enclose this sort of space in between with trusses. So let me just wait for this to open up. But this is that example file that I'm giving you. I'm just opening it up now. So if you go again to today in the modules of your Canvas shell, 8th of September, that's today, the first steps, right? I'll post this video demonstration lecture, but then also here's this Rhino model that I'm opening up right now, right? So you can see, right, first and foremost, that I've designed an atypical sort of atrium space, including some atypical sort of passages and tunnels and that sort of connect the two, right? So, you know, the first steps is you're going to immerse yourself within the space as a sort of camera. But first, let's talk about this just for a moment, right? So what I've done is I've not modeled the two buildings, right? I've just modeled the outside facade of this building and the outside facade of this building, and then some of these bridges in between, right? What you're going to do is you're going to span in between them in this sort of slot canyon space. These other two surfaces that I modeled are just to sort of cap off the ends, so that it doesn't look like it's just completely bare space when you set up your perspectives, okay? All right, so first and foremost, you can see that I have a few layers over here in Rhino, right? And so I have a layer called sub Ds, and that's what I've used to draw these surfaces. It's locked, so you can see them, but you can't accidentally select them and drag them around and move their position by accident, right? They're just there and they're locked. So if you unlock them, I guess you could move them, but you don't really want to do that because this is everybody's sort of starting position. I also have a layer here called top curve profiles, and that's these sort of bluish curves here. Just select them, right? These sort of top profiles for each of these, right? And so these are your sort of starting ingredients for developing a truss system, right? And you can do this any number of ways, right? We've done two different ways. I demonstrated one in front of you last Wednesday, and you can always go back and look at that lecture. You also over the weekend use a different way where you would span this with a surface somehow, right? And I'll go over a couple of different techniques to generate a surface based off of these starting ingredients. And then you pulled off the isoparms as the sort of as the curves that then become the sort of starting ingredients for your truss geometry, your truss systems. All right, so that's what I wanted to sort of demonstrate today, is that there's not one right way to do this, but we've gone over several different ways that you can begin to approach this problem, right, of spanning between this top edge, right, and between this top edge, right, to sort of put a truss lattice roof system over the top of this slot canyon space, right? Right, and you're going to be using Grasshopper in order to do that. All right. All right, so first things first. I don't know if you guys have noticed this, but when you get into perspective view, right, it's kind of tight. If you're in a sort of a really tight, sort of narrow space, it feels a little claustrophobic in here. That's because I don't know if any of you are photographers, but if you look at the sort of camera that you're looking through, if you think about this when you're looking through your viewports, right, particularly with your perspective view, think about it as a sort of DSLR camera, right? If any of you are good at photography, you know that you can change that zoom, and you're basically changing the lens length right? And right now, by default, our camera for our perspective view, the lens length is set to 50 millimeter, 50 millimeter, which is actually kind of tight. And so I want to go with maybe a wider angle. So one of the first things I'm going to do is in perspective view, I'm going to right click in this viewport, where it's the viewport label where it says perspective, right click. So it'll give me a set of properties here, and I can change, of course, from wireframe to shaded to render to ghosted, X-ray, etc. I'm just going to go down to the very bottom and pick viewport properties. And on my system, it just pops up a set of viewport properties over here on the right-hand side, docked with the layers and the other sort of properties. And so if I come over here, it's going to give me the viewport properties, the title, what is it? It's perspective. What kind of projection is it? It's perspective projection, not orthographic projection, or parallel projection, perspective, perspectival. But the lens length, so it gives me this sort of camera settings. And so both the position of the camera and its rotation where it's pointed, but its lens length is one of these settings, and I can change that right here. So a typical human eye looks at sort of maybe 25 to 28 millimeter. The typical sort of 35 millimeter camera. I'm just going to go with, like, let's say 25 millimeter to give it a wider angle. Now I can see much more of this sort of interior architecture in here, right? Let me just put myself in here as I begin to sort of place myself inside of this sort of narrow space, right? And so that's helpful if I'm trying to sort of situate myself in thinking about a camera, right? There's more than one place I could put myself in here in order to get a pretty dynamic and pretty incredible looking perspective, right? But now I've done all this for you. Now all you have to do is sort of span and create this sort of lattice system over top, right? Okay. So from time to time, once I get this system started, I'm going to go back to perspective view and sort of see spatially what's happening inside as far as spatial effect, lighting, shadows, those sorts of things, and just sort of generally check the sort of experiential. And so that's one of the things I want to do is just sort of get calibrate my camera so that it looks a little better in here. I can see a little more, right, as I place myself inside of this space, right? So if I was a human, I might be, sort of just like this, sort of at eye level in here. All right, so just going to go back out. I double click on the viewport, right? I can toggle back and forth between that viewport, filling the whole screen, or going back to just all 4 viewports at once, right? Top, front, right, and in this case, perspective. All right. Annoyingly, I picked a weird sort of color for this layer. I'm just going to change the layer color back to black so I can sort of see things a little more clearly, right? Okay. And then in perspective view, I'm just going to zoom out once more, and I'm just going to look at these 2 blue curves, right? These are the 2 things that I need. And I'm going to go ahead and open up Grasshopper. All right, that's going to load up. I'll just take a sip of my coffee. All right, so several different ways here. And what I recommend doing is just sort of watching. Don't try to follow along and then you might get lost. Okay, just watch what I do, because I'm going to show you several different ways. All the ways I show you are going to be rehashes of things that you did over the past week, right? So I just want to make sure that that you're sort of in the moment here and paying attention to the demonstration, rather than trying to follow along and then you miss something really important here. All right, so first things first, I have these 2 blue curves. Those are my starting ingredients. And so I need to bring those ingredients from Rhino. I need to reference them in a Grasshopper so I can start to build off of them in my parametric graph and here in Grasshopper. These are curves. So I'm going to go to Geometry, Params tab, Geometry, and look for this placeholder geometry where I can reference something in from Rhino into Grasshopper. I'll go to the curve option here, and I'm going to place 2 widgets. I'll copy and paste this, right? Because I have 2 curves, right? So first and foremost, just going to try to situate this so I can see both things at the same time here. I'm just going to take this first curve widget. I'm going to right click on it and say set one curve. I'm going to come over here and try to select this blue curve right? You'll see that there's now a grasshopper preview of it. When the widget is selected green, then that preview also highlights green in grasshopper. Do the same thing over here with this widget, this bottom widget, set one curve. Select the other blue curve here, all right? So now I have both of those curves referenced in the grasshopper, and I can start to build off of them. So one of the things I did as a demonstration on last Wednesday, a week ago, was I divided these curves, and then I started to connect the points from each of those divisions back and forth in order to create a sort of curve, sort of truss chord, similar to our very first recipe for generating a set of trusses, right? So I'll start there. Maybe I'll do that first, right? I'm just going to play around. Again, after you've seen all these demonstrations, you can begin to pick and choose which ones you like. And I expect everybody's truss system to be, they'll each have their own differences, right? That's sort of up to you to sort of choose how you want to approach this problem, right? But there are some workflows here that you can start with that I'll demonstrate here. So first things first, if you remember that recipe, I'll just quickly sketch this out. Again, sketching is your best friend, right? I have a curve like this and I have a curve like this. I'm generalizing, but I'm going to divide each of these up a certain number of times, placing these X's where those divisions would be. At each of those divisions, we get a point, right? These X's. We're going to start to connect these division points up with lines. Then for each of these lines, what we're going to do is we're going to place a point along them, project upwards, get this point, use this point and this point, then draw some sort of arc-like interpolated curve or spline through them, right? Then we'll divide each of these, the top and the bottom up, the same number of times, and then we can start to create the sort of trusses along it. So that's a set of sort of trusses along a sort of conventional truss system along each of these, or along the sort of length of this space, right? So that's the recipe, and that's the first workflow I'll go through here. So first things first, I have this curve and I have this curve. I'm going to go ahead and divide them. In this case, I'm going to go to the curve tab, right? So here's how I can create curves. Here's how I can find the properties of curves that are already created. Here's where I can do a lot of things with curves, both creating them and then using them later on to do other things with. So in this case, I'm going to go to division, divide curve, right? So again, the ingredients for a divide curve is the curve to divide. That's not a big surprise, right? We need a curve. Then the number of times to divide it, the number of segments, right? And then this other setting I'll just leave as false, right? I don't want to necessarily put kinks in this curve. There we go. All right. And so by default, the number of segments is 10. So I'll get 11 points, right? Okay. Just going to copy and paste this. I'll plug in the other curve as well, right? And now for the number of segments, right? Basically the number of trusses I want, that's going to be a variable. So I'm going to go ahead and go back to the params tab, go to my number slider, place that here. I'm going to double click on that slider label. I'll bring up the parameters. I can begin to change the settings of this number slider. I can constrain this to integers, can make the minimum something, like 1, the maximum something much larger, like 300 or something. Yeah, why not? Okay, and I'll plug this in for both the number of divisions here and the number of divisions here, and that way I'll have the same number of points to sort of connect up across to make the trusses with, right? So now depending on how many I do, the number of trusses and the spacing in between them, or the density, right? Is something governed with just this variable, the slide bar, right? Which is kind of handy. All right. Okay, so I have a list of points here, and I have a list of points here. I have a list of start points and a list of endpoints. I'm going to make a list of lines. All right, so I'm going to go to curve tool set again, go to primitives, several different ways to make lines. In this case, I have as my ingredients a start point and end point. So this is the A and B, make a line in between a start point and end point, right? Okay. So there's the start of each of my trusses as they span across. All right, so this is one way to do it, not the only way, right? This is the way I demonstrated in class, not the way that you used over the weekend. We'll get to some of the ways we can start to create a surface if you wanted to try out the things that you did over the weekend here. All right. But, okay. Now from here, it's about executing that same same recipe as before that I went over on Wednesday and that you guys did when you just made your first truss. How exciting. All right. So we have a line. Let's place a point along each of these lines. I'm going to evaluate each of these lines or each of these curves at a T address or T parameter. Plug these in. I'll right click where that C input is and say reparameterize those, right? That normalizes each line so that the starting point is 0 and the end point is 1. And therefore it lets me sort of find, let's say, a point along these curves somewhere. There we are. That's a quarter of the way along the length, or halfway along the length, or 75%, etc. Right? So I can move that around as needed. All right. So again, another variable here. I'll just start to put some of these sliders over here. In this case, I'll change the name. I'll right click where it says parameter, and I'll say, let's say curve inflection point, right? Because this is where the curve sort of inflects from sort of, the sort of the top, the crest of the sort of concavity of the curve, right? Curve inflection point. So we can change where that occurs along. There we are. Yeah. Right. Now we have all of these points, and I'm going to draw a line, right? In this case, I'm going to go back to curve, primitive. I'm going to use a different method for making a line. In this case, line by start point, direction, and length. That's another common way to make a line. The ingredients this time, I just have one point, but then I have a direction, in this case, the Z direction, and then a length, the sort of length of the line, or the height, in this case, of my truss, or the depth. All right, so in this case, another slider, and I'm going to double click on this one, and I'll give it an overly large number here as a sort of variable to use for the depth of my truss. I actually don't think I would go ever over 10 feet in depth. Yikes. So anyway, let's do that. All right. It says length. I'm just going to change this to truss depth, right? Okay. So later on, when I open this up, I can look at these and I go, okay, so here's the count, or the number, of trusses. Here's the, where the inflection point is located. Here's the height or the depth of each truss, right? And that way I can, I'm sort of labeling these so I can read this later on and start to adjust things and know exactly what I'm adjusting. All right, so I'm just going to go ahead and save this really quickly. Just save this to, really need to clean up my desktop. I'll call this 367 demo 01. All right, there we are. Okay, now I need to find the endpoints for each of these. That's what I'll do. Let's see here. I'll go to curve, and I'll find the start and end points for each of these lines that I just drew. I'm really just interested in the endpoints here. Look at that elevation. Isn't that crazy? All those points. I like how they sort of zigzag up and down. It's kind of a nice elevation. Anyway, super nice curve. So I have these points, and I have these points, and I have these points. I need to connect them up. And so I'm just going to go to curves, find that spline, that interpolated curve. All right, here we go. And one other thing, again, you don't necessarily know exactly why we're doing this yet. We'll talk about that in the second project, but I'm just going to do this really quickly. I'm just going to graft these endpoints and these points and these points into data trees before I plug them in. And so I'm going to plug in and hold shift while I do this. This one, and then this one, and then this one, holding down the shift key so that I can plug in multiple things at the same time, right? And I get these sort of green arches, right? Okay. And just so you can see, again, I can change the number, the spacing, and the density of these. I can also change the depths of them, right? As well as their geometry, if I want them to be sort of symmetrical, or if I want them to be loaded to one side or the other, depending on what the structural engineers tell me, right? All right. Okay, all right. And so now I have a set of curves here. I sure do. Just going to move these around, try to clean this up just a little bit. And I have these lines here, right? These are a list of lines. These are a data tree of curves. So there's going to be a little bit of a mismatch here. But nevertheless, I'm just going to go ahead and quickly try to clean this up. So if I, again, let me just think about this for a moment. There's 3 there. I might just need to graft these. Oh, you know what? Never mind. Let me just try to divide them. I'm just going to go ahead and divide these up. Yeah. Let's see what happens here. Divide curve. Divide these. Now I get 11. Yep. Okay. Because there's a number of divisions right there. Right. And I'm going to do the same widget. Just make a copy of it. Let me use these lines. Here we are. Okay. Now you can see when I move my cursor over, I have 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. Over here, I have 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, 0. We'll see. That might give me a slight mismatch here, but let me just double check and see if this will work out without me having to do any extraordinary measures. I'm just going to go ahead and plug these in and plug these in. No, that worked out really well, right? So now I have a set of vertical lines. I can take each of these and shift them. So again, this is something that we've done in the past, that if you need to refer back to this recording if you're trying this out over the weekend, that's perfectly fine. It'll be uploaded as soon as the demonstration's over, as soon as class ends. I'll work on getting that. I'm just going to make a copy of this because I'm going to shift this list of stuff over, shift this list of stuff over. All right. And so now I'm going to go back. I'm just going to make the crisscrossing diagonals. I'm going to take this list of points and then the shifted list of other points. There we go. Oh yeah, look at that. Wrap was set to true, so I'm just going to turn that to false. Wrap over here also set to true. Set those to false. Okay, I'm going to make another set of lines. We're just connecting the dots here. This shifted list with this unshifted list. Oh yeah, look at that. All right. Now we have a set of trusses. All right. Okay. Now I'm going to let's get in here. Oh yeah, look at that. All right, so structurally, wow, can you imagine? Oh, this would be like, I mean, this is like architectural porn. It's freaking sick nasty. All right. I mean, it's crazy. You know, this is like pretty tight. People pay a lot of money for architecture like this. Anyway, if you don't believe me, just go to the strip. Crazy spaces that you can't see anywhere else. All right. So again, at this point, I might start to go, oh, you know, it's kind of dense. Maybe I start to look at this, right? I could even begin to think about piping these if I wanted to, right? So in this case, let me just think about this for a moment. I'm going to go to Surface tab, pull out the pipe box here. I'll hold down the Shift key so I can plug in multiple ones. That radius seems ridiculously large. Those are way too beefy. 1 foot diameter, or is that radius? 1 foot radius seems a bit extreme for little, you know, truss members. Since I'm modeling here in feet, and you'll see that your units are set to feet in the file I give you. So if I thought about this, let's say the radius is 2 inches. So if you thought about 1/6 of a, I'll just go with 0.15 feet, right? Somewhere there. There we go. That's better. Oh yeah, that's so much better. Okay. I'm also going to plug in these chords. There we go. Put those a little bit of love in here. And then also these lines right here. There we are. Yeah. Look at that. All right. So that's one way of thinking about trusses that sort of span across this. Right? Yeah. All right. Let me go ahead and save that. I'm just going to start again from scratch. Let's talk about what you guys did over the weekend, right? You guys started with a surface, right? You started making some curves, lofted those into a surface, pulled those isoparms off the surface, sort of extracting a wireframe, if you will, and using those wireframe curves then as a way to sort of make some three-dimensional trusses, like similar to that other way of making trusses that we used, right? So these were the sort of two-dimensional, sort of typical bow trusses. And so let me just go back to bow trusses on steroids. Well, maybe I just have to do it in front of you guys. Yeah, I suppose so. All right. So first and foremost, let me just go to, again, as a quick reminder, right, what you guys did. I'm going to go ahead and start a new Grasshopper file. Sorry. Right. Okay. And so, as a quick reminder, some of the things you did in video 14 and 15, right? Let's see here. I'll just quickly put this in place with a few quick curves. All right. This is not to scale by any means. But let's say I wanted to create a sort of triangulated truss, right? A truss going between these two chords, and then spanning between those two chords, right? To make a sort of three-dimensional space frame truss, right? All right, so that's similar to what you guys have done before, right? I'm just going to go ahead and build this up again as a quick review. I'll bring in each of these three curves, copy and paste, copy and paste. All right, and maybe I'll just sort of think about these as left, top, right. Okay, so set one curve. There's the left curve. Did I submit? Oh, maybe I didn't select the right one. Set one curve. There we go. Set one curve. Here we go. And set one curve. There we are. All right. Ironically, this layer color is set to green, so they're already green. It's kind of weird. All right, and so we're going to divide each of these up. And not a big surprise. Let me go ahead and do that really quickly. Divide curve. There we are. Let me go ahead and make a slider. Constrain this to integers. Set minimum to 1, maximum to, like, I don't know, 30 or whatever it would be. All right. Now I'll go ahead and copy, paste this, paste. I'll plug this curve in and this curve in. All right. Yep, there we are. So we have a list of points, right? And I'm going to take each of those lists. I'm going to go ahead and shift them. All right, so go to sets and find the shift list. Not to be mistaken with the other kind of list that sounds very similar to shift list. All right, here we are. Do it for each of these. Copy and paste sometimes can be your best friend. Control C, Control V. All right. All right, and from here, it's truly just connecting the dots. So if I think about this just for one moment, I'm just going to go ahead and go to curves, lines, start point. So I'll go ahead and connect these with these, and I'll get a set of points, right? All right. I'll do the same thing between these and these. And then last, now look at this. What happened here? Anybody, did this happen to anybody? So what's interesting is, first of all, when you make a curve, right, or a line, Rhino remembers what the start point and what the end points were, in the order that you clicked. And then also when you set these, it also remembers the side that you clicked on when you were. So let me just see if I can fix this really quickly by saying set one curve, pick that end, set one curve, again, pick this end, and set one curve, pick this end. right? I think some of you had this problem, right? So if you didn't figure it out, these are lining up nicely, so it must be this curve. What I can do is I can select this curve, and the start point is over here, whereas the other start points for the other curves were over on the other side, right? So it's connecting the start point from this one up here to the start point over here. And so it's connecting them in the wrong order. So what we can do is we can flip the direction of this curve here in Rhino, right? So here I'm going to select this curve and go to Rhino, Analyze, Direction, select the object, go ahead and select this curve. I'm going to say flip, hit enter when I'm done, right? Now the start points and the end points are all going the same, right? So if you have a problem with that, you run into that and it didn't make sense, just come see me. You know, you can, I'm even happy to sort of look at it with you over Zoom outside of time if you just need a quick 5-minute meeting or something, right? So again, just email me. I'm for those who have had me in the past, you know, I try to be as responsive as possible with emails, even over the weekend and even in the evenings. So if you just have a quick problem like that, feel free to, and you can't get that to work even if you're watching the demonstration here, the recording, just ask me. All right, I can help you out. Okay, it's intuitive to me because I've been doing it for a long time, but I understand you would never dream that up necessarily if you haven't done it before, right? So again, with practice, you start to understand this stuff better. And so I absolutely do not want you guys spinning your wheels. A couple of you had these, right? So what happens is when I shift the list over, it takes that first item and shifts it to the back and keeps it, right? And so again, the first item and the last item are being connected here. So I'm just going to go to these shifts widgets. I'm going to go to the wrap option. I'm going to say set the Boolean, turn the wrap off, set the Boolean from true to false. Okay, so in this case, false, right click, set Boolean, toggle that to false, get rid of those. Saw that in a couple places, right? Not a big deal. I didn't take anything off. It's more of a learning experience at this point, right? All right, so I've taken this shifted list with this list. I can take this shifted list with this list. All right. This will get really complicated. It'll start looking like a bowl of spaghetti here pretty soon. Take this shifted list and connect it up with this unshifted list. All right. Now we have the start. Now we need to do the exact opposite. So I'm going to put the line, another set of line widgets here. Paste. There we are. I'm going to pull this one with this shifted list and pull this one with this shifted list and this one with this shifted list. And if my logic holds clear, I should have, right? I mean, you guys probably had this pain, right? It's like, which ones did I connect up and which ones have I not yet, right? So having some sort of system to sort of keep track of that comes in really handy. What I'll do is I'll start to put these together here. Yeah. What you can do is you can go and select these, and then they'll start to highlight the green rubber bands so you can trace them back if you need to sort of understand what's been connected and what hasn't, right? So this is the sort of base recipe for making three-dimensional truss from 3 curves, right? And then, you know, building off of that, instead of just doing one, like you guys did originally, I'll go ahead and save this, right? I'll call this 3D truss, all right? And again, just get in the habit of saving early and saving often, right? That's a key thing to remember. Whenever, I mean, that's just a good life rule. But it certainly works when Revit and Rhino and Photoshop and Illustrator. So anyway, back to this. One of the things I'm going to do is I'm going to generate a bunch of curves that we can use for this sort of recipe, right? By making a surface that spans these things. There's a lot of different ways to make surfaces in Rhino. So let's just go back. I'm just going to go ahead and close the Grasshopper for now. Let's just look in Rhino. And let's take a look at the curve creation, or sorry, the surface creation tools, right? So if you think about the sort of toolbars along the left-hand side, right? It starts with points. We use points to make curves. We use curves to make surfaces. There's a hierarchy here. Not a big surprise. There's lots of ways to make curves, ways to edit curves down at the end, lots of ways to make surfaces, and then several different ways to edit surfaces, like I can fillet them, join them, combine them, chamfer them, unroll them, rebuild them, etc. Right? Okay, so if I go to my curve creation tools, right? It's this one right here. If I click and hold, you can see that there's umpteen different ways in order to make surfaces, right? And each one has a sort of set of ingredients that it needs, oftentimes dealing with points and curves, right? So as the ingredients and maybe a couple of new parameters to add in. So if I wanted to say surface from planar curves, and I have a set of closed planar curves, right? I can fill that in with a planar surface. I can loft things, which means I can think about a set of a sectional sort of section curves or profiles, and then skin along them, right? That's what you use for your assignment over the weekend, right? You drew a couple of curves and then you sort of skinned or lofted them, right? From the sort of as the sort of sectional profiles, right? There's a couple of variations on this. One is called sweep with one rail, and one is called sweep with two rails. So let me just demonstrate this. What I can do is I can take any sort of profile and I can sweep it along a path, right? So it's like kind of like extrude, right? So with extrude, I can take a profile, right? So let me just type in extrude, right? And I'll pick, like, let's say this curve, right? And I just give it a direction, a straight direction. I can extrude it in that direction, up or down, right? Now with sweep along a rail, instead of just picking one direction that's straight, I can actually draw a curve and sweep this or extrude this along a curve. So the direction can actually change, right? So let me just demonstrate that really quickly. What I'll do is I'll draw some sort of rail curve here. Kind of weird, but whatever. And let me just sweep this curve, so a rail, and then this curve along it, right? Oh, that's really creepy. Rebuild. Let me do it the opposite direction, maybe. It's so goofy. What in the world? Oh, I see. It's because this thing expands out. That's dumb. Here. I'll make this a little less pronounced. This has everything to do with the geometry I was using and not really anything to do with stuff you need to concern yourself with. Right. So what I'll do is I'll also just change, so yeah, give this a little three-dimensionality here. That would help. All right, great. So I'll go ahead and just sweep one across the other really quickly, just so you can see what this does. Here's a rail, and here's a cross-section curve, right? And so it's swept one across the other. And depending on which one I select as the rail, right, I get different results, right? So this one is sweeping this shape across this rail, right? Yeah, not too shabby, right? In fact, that's how they generated the master geometry of Waterloo Station, right? And one of the things we can do is, instead of using one rail, we could do two rails. So for instance, if I move this one to be a second rail, aha, look at that. All right, so now I'm going to say sweep along two rails. It's going to ask me, you always go to the command line, select first rail, there it is. Select the second rail, here it is. Now select any sweep shapes, there's one, right? Now it's going to sweep this one along both of those rails. Oh yeah, look at that. All right, so that's one way we can begin to negotiate this geometry here with these blue curves, right? We could begin to make a shape up here, right? We can make several across if we wanted to, and then sweep it along these two rails. So that's one way I'll think about this. Let me just try it. And what I'm going to do is I'm going to go to my control point curves. That's how I can draw these nice splines. And there's no right or wrong way per se, but one of the things I'm going to do is I'm going to really try to use and be careful with where I'm clicking and what I'm snapping to. So I'm going to try to snap there. There's an end, not vertex, right there. Okay. I'm just going to make sure that as I move across that I'm going in the right direction here. I'm just going to make a curve right there, right like that. All right. Now, if I select this, right, you can see that's just basically a line because I only have 2 points. right? So maybe I want to rebuild this curve and give it some more points, and then I can begin to sort of change the shape of this curve, right? So let me go ahead and do that. I'm just going to do this manually in Rhino. Okay. Here's a set of curve tools. Here's the sort of curve modification, sort of curve tools here. Right, I click and hold out. This is fillet one. Right. If I click and hold it out, I can do a number of things. But if you write down one thing for today, it's rebuild curve. Right. I can just type in rebuild. Right. And you can see that there's something that I can do here. I can change the point count, right, from 2 to something like 8. That'll give me a lot more points across. And then the degree of curvature, right? The first degree curve is what it is currently, which means it's just a straight line segment. If I change it to third degree, that's what I want. Then I can make it something nice and smooth like a spline. 8 points seems a bit extreme. Maybe I'll switch this to 4 or maybe even 3. Let's see. Yeah. Why not, right? And so that's going to let me kind of select just this point right here. It's similar to how we used a bow truss. I'm just going to move this up in Z. I'm just going to select that point. Oh yeah, look at that. All right. And so if I think about this, there's a lot of visual clutter on my screen, but I just made this curve, right? And now I'm going to sweep this curve along these 2 blue rails. All right, so let me try that here. I'll try this in Rhino first. Sweep 2 rails, select the first rail. Okay, select this one. Select the second rail. Go ahead and select this one. Now select any sweep shapes. I can select more than one. I'll just go ahead and select this one because I only have one. I'm going to right click to hit enter. All right, there's a surface. Excuse me. Whew. I'm going to go ahead and hit OK. All right. There we have it. So a couple of things here. One is, you know, the sort of isoparm spacing and density, right? I might go ahead and change that. So just like I rebuild a curve, I can rebuild a surface. I can type in rebuild. Right. All right. Let's see. Just go ahead and select the surface. And similarly, degree is already changed to 3. I'm just going to go ahead and change that to 3 for both U and V. So now we have a U and a V direction. That'll make more sense in project 2 when we talk about surface, right? But now I can change the count. 76, maybe, I don't know. Moving across, instead of 3, maybe we go with 6. I'm just going to turn on preview and sort of see what that looks like. So you can see in this green area, you can start to see a more even distribution. Yeah, I kind of like that. Why not? Yeah, sure. Really, all I want are these 80 here. I can leave this as 3, couldn't I? Yeah. And hit preview one more time. There we are. Yeah, I kind of like that. I'm going to hit OK. All right. Okay. And so now I have another choice to make, and that is, you know, when I extract these wireframe and start to make, let's say, a third chord, right? Do I put those the outside or up, or do I make them down? I'll just pick one or the other here. But I'm going to go ahead and extract wireframe. Just type in extract here, extract wireframe. Okay. I'll go ahead and select the surface. I'm going to go ahead and change the layer to layer 05. And I'm going to go ahead as the active layer. So when hopefully I make these, extract the wireframe. There we go. So I have these curves. They're magenta because that's what my selection color is. They're selected right now. I'm just going to double check and make sure they're on layer 5. All right, there we go. I'm just going to change the color of layer 5 to something that stands out a little more. Pick this early Tampa Bay Buccaneers orange, sort of creamsicle color. Turn that roof off. Now you can see that I have just those. Oh yeah, looking good. All right. Okay. Just like before, if I put these all on the same layer, I can right click on them, say select all the objects just in this layer. And just like before, I could make a copy of these upwards, right? In this case, I'll go upwards. Just going to turn on my ortho, so I just make sure I go straight up in Z just a little bit here. There's those new ones. All right. Now I just made a new set, right? The old set were selected. I'm just going to say cell, SEL, last, right? That's short for select last. That'll select all of the last objects from the things that were created from the last command, right? So now I get those new ones. And I'm just in plan, I'm just going to look at these. I'm just going to move them over. And you can see hopefully in perspective what I'm doing here, right? I'm just sort of moving them so that they're staggered in between, right? I'm just going to get rid of these rails that go down the center here. Yeah. And then there'll be down at this very end, there'll be an extra one that I don't need. I'll go ahead and delete that. Yeah. All right. And now, last but certainly not least, it's time. I'll just go ahead and save this really quickly. Go ahead and open up Grasshopper. And let's make one of these three-dimensional trusses. Right. Okay, in this case, I'm just going to pick these curves and say, set one curve, and I'll pick this one. And I'll set one curve, and I'll pick, it's already starting to pick this one. And then set this last curve, and I'll pick this one. All right. Now I have some sort of directionality problem. Right? I suspect it's this way from both ends. So it's these top ones. For some reason, these things. So I'll go ahead and cell. Remember, cell last, select the last items that were generated. In this case, a copy. Okay, cell last. And I'm just going to go to Analyze, Direction, Flip All. All right. Hopefully that fixes it. It did not. What in the world? Why did that not flip? Direction. Seriously, flip. Oh, for Christ's sakes, what in the world? Why? Why? Oh. Bear with me for just a moment. Let me just try this with the second one over and see if this is consistent or not. So I have this one. Okay. And I have this one. And I have this one. Oh, that looks good. So it must just be this end one for some reason. That's weird. Options. Oh, sorry. Analyze, direction. There we go. Flip. And hit enter. All right. Let me try this one more time. I'm just going to go ahead and set one curve. Pick this one. Set one curve. I'll pick this one. Right. Set one curve. And I'll go with this one. All right. It's still screwed up. Why? Why are you doing this to me? Oh boy, direction. Flip. Okay, this should be the last time, I hope. Okay, sorry, sloppy modeling, but there it is. All right. Okay, so if I wanted to do this across, then what I would need to do, right, is come up with a way to, in this case, what I would do is just copy this, just like you did before, right, over the weekend. Set one curve, there's that one, set one curve, there's this one, said one curve. There's this one. Okay. Now that's not the most economic way of doing this, right? I could do this across all of these, however many times I have, 71 times. Okay. Now, let me see again, if thinking about this just for a moment, if there's a way to think about using data trees in order to sort of make this process go smoother, right? No doubt there is. What we would do is we would take all of these curves, we make a copy of them, copy them over, make another list of curves, right, in these placeholders, then take the top curves. We would start to, once we get these points, it's just, we start to get data trees, right? Let me see if I can figure that one out. And if so, I'll give you that one as an example file and post it. It seems really easy in theory here, but much like that meme of the ship going through a slack canyon and then getting stuck in the Suez Canal, this would probably work if I wasn't doing this in front of you, and we'll see if it actually will, or if something goes terribly wrong and I panic under the pressure. So, all right. I'll start to make some curves, some curve placeholders here. All right. And let me just make sure these are going to be the peaks. So I'll say set one curve, and I'll say cell last. Nope. Oops. That's not what I want to do. Set multiple curves. There we go. Okay. And I'm just going to go across. Right. Actually, before I do that, let me try to put these all in different layers. That would be helpful. Yeah. All right. So I'll call these curves 01. I'll make another layer, call that curves 02. I'll make one more layer, curves 03. All right. So curves 01, we already have curves 02. So let's say cell last. Nope, it's not going to work. Okay, so I'm just going to go to the elevation. And I'm just going to see if I can. Yeah, I'll just do this really quickly in perspective view here. Just going to select all of these. I should have put them on different layers. Sloppy. At this point, it might actually just be easier to regenerate them, but nevertheless, I'll persist here. All right. There we go. There's some more. Maybe I just drag from right to left and select multiple at a time. Just making sure I'm selecting the top bunch, not the bottom bunch. Oh, I accidentally didn't hold shifts down. That was a dumb mistake. There we go. Oh yeah, look at that. All right, cool. Almost there. There we are. All right, so I have all of those top ones selected. I'm just going to change their layer. All right, curves 02. Why not? All right. And then I'm going to select everything on curve 01, select objects. I'm just going to make a copy of them. Let's see here. Copy from there and and I'm just going to make a copy of them just in the exact same place. Right? Click and then click in the exact same place. I'll take those copies. I'm just going to turn those to curves 03. Right? So now I have turn these layers off, and you'll see I have curves 01, right? Which will be all of the sort of left bottom chords. I'm going to turn off this right bottom chord at the end. Okay. Then I have the top chords, curves 02, and then you'll see this here in a moment. Here's the left chords. The curves 03 will be the right chords. Okay, so I'll turn those off, and I'll just delete this bottom left chord there. All right. So I'll turn all of these on at once. You'll see, I think, what I'm going to do here. I'm going to say, okay, these will be the bottom left, set multiple curves. In this case, I'm just going to go curve 01 and say select all the objects on layer curve 01. hit enter. I think I had these original curves selected. I'll just go ahead and delete those. Okay, yeah, I'll go ahead and redo that. Select, set multiple curves, select these, select objects. There we go, a little cleaner there. Okay, there we go. Right click on this, set multiple curves, go to Curves 02 layer, select all the objects there, hit enter. And then this third set, select multiple curves, select all the curves on this layer. There we go. All right. Okay, now I'm going to divide each of these. All right. So curve division. How many times? No, we'll make that a variable. So I'll add a number slider. I'll constrain it to the set of integers. Set the minimum to 1. We never want to divide by 0. That would be terrible. Mathematically, just math doesn't like that. All right. Okay, there we go. I'll go ahead and copy, paste this, plug these set of curves in, paste this, plug these set of curves in. All right, look at that. Now we're cooking. All right. Now it's all about connecting the dots. Let's do the first set of dots that are the easiest. Here we go. Okay. Why is it doing that? All right, let's see what happens when I do this set. Of course. This set worked out pretty nice, didn't it? Yes, yes. All right. Let's try another set here. Copy and paste. So let's try this one to this one. See what happens. Okay, the order must be messed up here. That's okay, we can reverse the order. That's fine. All right. That's just super. All right, so these look good. So it must be the reversing the order of this one. All right, so we can go to this list and we can say reverse list. Let's try reversing the list and then plugging those in for each one. That did not work. Sadly, there's always something. Maybe if we reverse the tree. Yeah, I'm not going to be able to figure this out. There's something happening here where it's not connecting up the one-to-one. I mean, the logic here is fine, but for some reason, the sequence of these curves is off somehow, which is, it's always a pain when that happens. Right? And it's kind of situational at this point. I'm not sure if you would replicate the same thing on yours. I suspect it's me not thinking a couple steps ahead here. So anyway, back to where we were, the 3D truss, right? I can, again, this is not going to be the most optimal way of doing it, right? But I can go back and copy and paste this a few times as I move across and do this for each one, right? Over the weekend, that'll be my homework. I'll come up with maybe a better way of doing. Let me just finish this out, right? Doing these so that we can use some data trees and you won't be back in square one here. But as you can see, it doesn't take too long if you do a set of these, right? In order to begin to sort of create this, again, this sort of similar truss system to what you did over the weekend, right? And these things, of course, you know, this thing dips down, gets higher in some places, it starts to inflect in other places, right? Okay. So that's essentially your assignment over the weekend, right? Is to try to generate, try it, right? Try generating a truss system, right, across to span across this. And again, on Monday, I want to see the results, right? By Monday, I want to see the results. A couple of screen captures will suffice for Monday, right? I'll specify that. I'll say like maybe just 3 quick shots of, sort of showing maybe an overall sort of shot from above, and then a couple of, thinking about maybe two example perspectives in the space here, sort of thinking about how you're thinking about this initially, right? Because not only are we designing the system, but we're also thinking about the best ways to generate some experiential perspectives of it. So, again, if you start to think about, 2 different positions underneath this thing, and we can start to talk about how to frame your perspectives, then again, we can have that conversation next week as well, right? All right. But on Monday, I want to sort of see, okay, I want to hear from you, and I'll see it obviously when I start to look at the assignment submissions, where you're having problems, right? So we can begin to sort of troubleshoot and debug some things. Like I said, maybe I'll have a sort of a better workflow for you to demonstrate, where you don't have to sort of copy and paste all of these things, but you'll actually have, there's a way to do this with data trees and keep everything straight, and it shouldn't be that difficult. But for whatever reason, my logic is just a little off here. And, unfortunately that happens sometimes. It might just be that I need to graph the lists before I start to plug things in. We'll see, I'm not sure, but clearly something was off, and I'm not going to try to debug it in front of you guys and waste your time. Okay. All right, so again, this is several different ways you can begin to either take those curves and begin to just generate some typical trusses between them, or what I like, I think is better, is sort of generate a surface. There's lots of different ways to generate a surface here across the roof, and then to use that surface to extract its wireframe after you rebuild it, right? So you get a sort of critical mass of chords you can use for the sort of appropriate amount of trusses, which would be, this is quite a long expanse here. So you're going to have 60 or 70, or maybe you need 80 of these, right? But then it's just going back and forth and having some patience, right, to sort of, again, plug each of these sort of top and bottom chords in here in order to sort of create this sort of really intricate truss system. And it beats the hell out of drawing these each one manually, right? But at the same time, thinking about sort of a parametric graph again, I will look at this and sort of see how maybe I'll try to again over the weekend try to generate a sort of streamlined version that you can plug into. Okay, but I think this is just good practice, right? Again, practice. So the more you do this, the easier it starts to get, and the more things start to snap into focus in your brains, right? So I don't actually have a problem with this sort of maybe potentially rote exercise of repetition where you're going through this and each time trying to sort of keep these things straight, but doing it over and over again, at least for now, right? As your first sort of first stab at this. Okay, so again, try this out, right? The workflow, and then again, some of you will have some disastrous results. Some of you will have some pretty interesting results. Some of you will have results that you anticipated. Some of you will have some happy accidents that maybe you do something that wasn't anticipated, but actually is more interesting than what you anticipated. That's fine too. But that's the kind of conversations I want to have, right? Where did things go off the rails? If that happened, then I'll get you back on the rails, right? And in the meantime, we'll talk about, again, the sort of capacity to generate lots of different options, right? Once you start to build in certain variables in this, you can start to tweak them and start to show me lots of variations of the same system, right? Okay, and so that's the goal here. Then we'll start to talk about space and collaging things up in between rendering, line work, and photoshopping context and what you would say entourage into. So humans, vegetation, lighting effects, those sorts of things. Okay. All right. So again, I'm going to go ahead and stop sharing, and I'll stop recording. But the recording of this will be up soon, and And don't forget that this example file, this Rhino file, that's it. Everybody starts with, that's already posted on Canvas. And if I generate anything new as far as files go that I think might help you, I will post them and I'll send you an email over the weekend. If not, then you'll probably hear back from me on Monday. Okay. Again, once again, if you have any quick questions that pop up and you're just like thrown for a loop and something's not quite working the way it looked in the video, just shoot me an email. Okay. And good luck and have a nice weekend. I look forward to seeing you on Monday, and we'll talk about the results and any problems that popped up, as well as any of the exciting things that you guys generated then. Okay. Okay, great.